Yes. Yeah. Yeah. Good evening, all. So myself, I am Vijay. Like I hold 20 plus years of experience in different technologies. So I've got 10 plus years of experience in this data engineering courses like big data, Hadoop, Spark with Scala, Spark with Python, right? So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah. Anyone please confirm me?
Yes, it is visible, sir.
Fine. Fine. Thank you. So as part of today's demo, I'll be discussing what is Apache Spark, what is Apache Spark and why PySpark, and need for PySpark. And generally is Python implemented using Scala and Python, which is the better one, and difference between Python and Scala languages, and PySpark features, and real life usage of PySpark and PySpark job market, the current job market of PySpark. Yes. Starting with why Apache Spark. What is Apache Spark? So the history of Apache Spark. So evolution of Spark, it was developed by Matai Zaharia in AMP Lab, Berkeley in the year 2009. So Spark was introduced in the year 2009. Spark was open sourced in the year 2010. It was made open sourced in the year 2010. And Spark was donated to Apache Software Foundation. It was donated to Apache Software Foundation in the year 2013. Yes. Apache Spark, if I want to define Apache Spark, right? Yes. I define in 5 lines. Spark is an open source distributed cluster computing framework. It is a distributed cluster computing framework with in-memory computation in parallel process style for large-scale data processing. It is an open source distributed cluster computing framework. In-memory computation means storing and processing both happening in the memory level in parallel process style used for large-scale data processing. It is a very high-speed processing execution model. Spark is a very high-speed processing execution model which processes huge data, that is big data, at a very high rate of speed. So yes, the, the very high rate of speed for processing and execution, which process huge data at a very high rate of speed. Yes. It is a general engine, Spark, it's a general engine for big data analysis, for processing, and for computation, right? Yes. It is a general engine for big data analysis, for processing and computation, right? Yes. So why PySpark? Why PySpark means, right? It's a Python API. It is a Python API to use Spark. It is a Python API to use Spark. Yes, it is one of the lightning fast technology that is designed for fast computation. It is one of the demanding tool for data engineers, right? SpiceSpark is one of the demanding tool today for data engineers to work with huge data sets. It's a lightning fast technology that is mainly designed for fast computation, for fast processing. Yes, PySpark, if you see this in-memory computation, mainly this in-memory computation, previously we have got big data Hadoop, right? We won't see this in-memory computation in that. We see all the remaining. It's a open source, distributed cluster computing, parallel process for large-scale data processing, all the other features you see. But in-memory computation means data storage happening within the memory, that is RAM level, and processing within the memory level. Your data object is going to be divided into smaller partitions. Those partitions are going to be distributed across multiple RAMs of multiple systems and are processed parallelly. So distributed storage and in-memory computation, parallel processing, right? So because of which you see very, very high speed, right? Yes, as compared with any other technologies, Spark has got very high speed. Okay. And I said it is a lightning fast technology, and it is used for running a distributed SQL. It is used for running distributed SQL. Means yes, creating data pipelines and ingesting data into databases, running ML algorithms, and working with graphs or data streams. So, so why PySpark? For all these things, running distributed SQL, creating data pipeline, ingesting data to databases, running ML algorithms, working with the graphs or data streams. So yes, need for PySpark means today like huge data is getting generated through offline or through online. Huge data is getting generated. So like data from the existing customers, the new customers, from the logs, and for the huge data which consists of hidden patterns, unknown corrections, market trends, right? So we need to explore the data, we need to extract the useful informations from this raw data. So we need to have a technology, right, which is where it's very scalable and flexible, right? So PySpark is such a kind of tool. So combining Python and Spark is very efficient way for the world of big data, right? So Python and Spark combined together we call like PySpark. So if you see which one is most preferred, like Spark with Python implementation or Scala. So Python or Scala language. See I can say frankly saying, right, Spark by default built using a Scala language. What is that? Spark by default built using a Scala language. But previously, the initial days, right, Scala was mostly preferred in 2016, 17, 18, 19. Scala language is mostly preferred, but today industry going with Python, where Python has got many modules, thousands of modules it is providing for different environments, especially today, like the talk of the industry, like if you talk at the data science, machine learning, deep learning, AI, all this, they are using Python as the implementation language. They're using Python as the implementation language, right? So Python is mostly preferred for implementing Spark. Even Scala also is used. Yes, as compared to it today, like usage of Python. If you are saying only Spark, if you are saying only Spark means it is implemented in Scala language. If you are saying PySpark means it is implemented using Python language. You see the difference between Python and Scala language? Yes, Scala means scalable language, extensible language, extended from Java language. So Python is a interpreted and dynamic typed. Python is interpreted and dynamic typed. Yes. Scala is statically typed. Python has a huge community. Scala community is smaller. Yeah, Scala community is smaller. Yes. Python has 89,300 inbuilt modules. Yes, supporting for different environments, right? Scala has no such module. And Python contains powerful libraries for data science, for graph algorithms, for streaming, for scale. Okay, for all this. Scala also has got libraries, but little less as compared with Python, right? Yes. PySpark features one by one feature, right? Yes. In-memory computation, right? The main feature of PySpark, in-memory computation, means the name itself saying in-memory, memory level, right? Storage and memory level processing, the data getting stored in the memory. In the case of big data Hadoop, right? Data stored in the disk and get processed in the RAM memory, right? But here both storage and processing both happening at the memory level. That's why very high speed you are going to see for this, right? Yeah, storing and lazy evaluated. And active evolution and lazy evolution. Lazy and active evolution, which one is better? Yes, active evolution means immediately whenever defined executing. That is what active evolution. Lazy evolution means, see, just like whenever daily you are getting the notes, daily if you are going through that, or daily if you are reading it, that is what active evolution. Whenever notes forwarded, you are just immediately going through it. A lazy evolution means whenever exam is kept, then only you are just going through the notes. That is what lazy evolution means. Active evolution means whenever you're defining something, immediately executing its active evolution. Lazy evolution means whenever required only they are getting executed by providing some actions. Whenever you provide some action only, the data flow gets executed. Means just like in programming language, functions are there. Function, if you call only, it executes. If you won't call, it won't execute. The same way, the data flow or the Spark, right? So lazy evaluated. If you perform any action, then only it executes. Otherwise, it won't execute. That is what lazy evaluated. So here, when some action is performed, then only the data flow executes right from the starting to the end. Partitioning, Spark data is divided into partitions. Then only the data will be distributed across multiple systems running parallelly on a single data object and are executed parallelly because of this parallel processing, distributed execution, in-memory computation, you see very high speed for Spark. So that's why combining Python and Spark is the efficient, right? And the Apache Spark community came up with a tool called PySpark. Yes. Immutability means they are immutable in nature. The original data object is not going to get modified. It will be as it is. Spark data objects are immutable. If you perform any operations on the data, then the original data object is not modified. Then the original data object is not modified or changed. Persistence means okay, with a simple way. For example, you have already executed a transformation. You already executed a logic or a transformation. No need to re-execute again. Again, reusing, just reuse. Don't re-execute. Just reuse with already executed transformation output. Reusing already executed transformation output instead of re-executing again. Fault tolerance, as Spark provides powerful fault tolerant model. As Spark data is distributed across multiple systems, if any system goes down, then Spark has the capability of regaining the lost partition. Spark has got powerful fault tolerant, I said, right? A real life usage of Spark, real life usage of PySpark is used in the commercial sector, in the healthcare sector. See, in the commercial sector, if I talk about the commercial sector, like Apache Spark real-time processing, bank and other financial fields, they're using Spark to retrieve the customer's social media profile and analyzing or gaining useful insights, and also like credit risk assessment and fraud detections in healthcare, in analyzing the patient's records along with the previous medical reports. Yes, in entertainment industry, right? This entertainment industry, right? The popular OTT platform like Netflix using Apache Spark for real-time processing, that parsing like personalized online movies or web series. It processing around 450 billion events per day over that are streamed over server-side applications, trade and e-commerce. The leading e-commerce websites like Flipkart, Amazon, all this they are using Apache Spark for its advertising. The other websites such as Even it is going to provide enhanced customer experience and increases the overall performance. So the topmost e-commerce sites, the using Apache Spark for advertising, right? Yes, and for kind of recommendations, and even for tourism industry, right? It is widely used to provide advice to millions of travelers by comparing hundreds of tourism websites. In this way, there are many use cases of the PySpark mostly used today. Has got a very high speed, right? Yes. Motivation towards Spark. Why? See, already we have got big data Hadoop, which has got very high speed. As com as compared to that Hadoop, right? Spark has got very much high speed. Motivation towards Spark. Yahoo has conducted a test. Yahoo has conducted a test, right? It has taken a table of 100 TB consisting of 1024 columns. Task was sorting based on 16 columns. It was sorting based on 16 columns. What is the time taken, right? Yes. Time taken by for sorting based on 16 columns. This sorting is 100 TB data. Sorting based on 16 columns. Time taken by Oracle around 3.5 days it has taken. MySQL has taken around 6 days. Teradata has taken. Teradata, a specialized database used for data warehouse. It has just taken 4.5 hours. Netija, another right? Netija is another. It's specialized database used for data warehouse purpose. Just taken 3 hours. Finally, Hadoop has taken 3.4 minutes. What Hadoop has just taken 3.4 minutes. Means see the speed of this Hadoop as compared with this, which have taken days of time. These have taken hours of time. These have taken minutes of time. These are days of time. These hours of time. These are minutes of time. Spark is 100 times faster than Hadoop, right? Spark is 100 times faster than Hadoop, right? Means already Hadoop has got very high speed. Just it has taken minutes of time, but Spark compared to this Hadoop, Spark is 100 times faster than Hadoop MapReduce. In Hadoop, there is a MapReduce execution model. Previously, it was very much used. Now it got outdated. But Spark is 100 times faster than that. That is what the motivation towards Spark, very high speed as compared with other things, right? Yes. So just now I said Spark can be coded with Python language, multi-language support. It is multi-language support, right? Yes. It can be coded with Python language. It can be coded with Scala language. It can be coded with Java and or language. Coded with Python language, Scala language, Java language, and or language. Spark was default written in Scala language. Spark was default written in
Sir,
Scala.
can you repeat again, sir? Hello,
Which one?
sir, can you repeat again time taken by, sir, time taken by Oracle will take a 3.5 days. That
Mm,
means a process which is taking Oracle 3.5 days, MySQL will take 6 days.
yes.
Actually, the call
Uh,
went automatically disconnect, so I didn't understand properly.
Okay, so here 100 TB of data. So Yahoo has taken 100, a table of 100 TB consisting of 1024 columns. The task was sorting. Generally, we sort on a single column based on a column or two columns. But we say based on 16 columns, sorting has to be done. So Oracle has taken around 3.5 days to process it. MySQL has taken around 6 days to process it, to handle this. But Teradata and Netija, these are specialized databases used for data warehouse purpose. They have taken hours of time, 4.5 hours, 3 hours. Hadoop has just taken 3.4 minutes of time. As compared to this, already Hadoop has got very high speed, which is taking minutes of time. But Spark is 100 times faster than that Hadoop.
Okay.
In Hadoop, we have got MapReduce execution model. MapReduce execution. We say it got outdated now. Hadoop MapReduce. So instead, we are going with Spark, which is, if you see, as compared with that, Spark is 100 times faster than this Hadoop. Means if you see, then what will be the speed of Spark once you assume it has taken minutes of time? Then what will be the time taken by Spark, which is 100 times faster?
2 seconds only.
In seconds it will be there, right? That's why Spark has got a great
Right.
demand today. Spark has got a great demand today because today everywhere you see like huge data is getting generated, not in GBs or TBs. Beyond that, in petabytes of data is getting generated. The industry is expecting quick results. So at the at one end, the events are getting generated. At the other end, the events has to be processed at a quick rate of speed. So we need to have a technology which is going to process the events or the data at a very high rate of speed. So Spark is one of that, right, which can process the data at a quick speed, right? Yes. Spark can be coded with Python language, Scala language, Java, and R language. Mostly preferred are these two. By default, it is built using Scala language. Spark default written in Scala. Scala is the native language of Spark. Scala is what? The native language of Spark. So comparing Spark with other technologies, right? If you are comparing Spark with other technologies, we have got a technology like Tej. And if you are comparing with Spark, both follows DAG model. DAG model means directed acyclic graph, acyclic, not cyclic, acyclic graph model. But what is that commonality you observe? Both are DAG model. But Tej doesn't follow in-memory computation, but Spark is a in-memory computing system. So Spark has got high speed as compared with Tej. So Spark has got very high speed as compared to Tej. Other in-memory computation systems in the market. Do you see any other in-memory computation systems? Means yes, HANA is there. HANA and Spark, if you compare, both are in-memory computing systems. HANA and Spark both are in-memory computing systems. But HANA is not distributed, but Spark is a distributed RAM. Even bigger data objects can fit. Even bigger data objects can fit into this, right? Yes. Spark is distributed, but HANA is not distributed. Spark is mainly designed for batch applications. Mainly, there are two types of applications, right? Mainly, there are two types of applications. Online applications, online up. See, we are not going to deal with online applications. This Spark, this Hadoop, Spark, all these are not for online applications. It is not for request response architecture. Response means if you give a request, getting response. So we are not creating any web applications or online applications. Online applications means user interactive applications. User gives the input. If you give a request, you are going to get response, not for those applications. Batch applications. Second category of applications are batch applications. User non-interactive. User won't give any input here. Iterative algorithms. So batch applications. And for iterative algorithms, see, most of these ML, machine learning, or this data science called of algorithms, they are iterative in nature. You will be applying this iteratively on the same data until the error becomes zero. Interactive queries are SQL queries, and for streaming and for graph algorithms, Spark is mainly designed. And even if you just differentiate between Hadoop and Spark, right? Hadoop MapReduce or Spark. Observe carefully Hadoop MapReduce or Spark. MapReduce drawbacks. Hadoop MapReduce drawbacks. Transformations cannot be reused there, but in Spark you can reuse. Bad for iterative algorithms. Actually, if you see the heart of the analytics, is ML. See, bad for iterative algorithms, and that too not a flexible parallel process. Map reduce first mapper phase, then reducer phase has to execute. After executing mapper phase, then only reducer phase. Until then, reducer cannot execute. But Hadoop, this is meant for parallel processing. Parallelly, they has to execute, but they are executing sequentially. That's why I'm saying not a flexible parallel process and slow processing as compared with Spark. Slow processing, right? Slow processing. Transformations cannot be used, bad for iterative algorithms, not a flexible parallel process, slow processing. Okay. Spark, and there is another, we used to have Apache Pig. Previously, there was Apache Pig. It is also a data flow language. See, what is the commonality you observe between Spark and Pig means? Both are data flow languages. Both are data flow languages. So Pig is also a one kind of scripting language. It is one of the best scripting language. For example, if you can see the importance of Pig, very less coding you used to write. 100 lines of Java code we can write within 6 to 7 lines in Apache Pig. So previously in Hadoop, big data Hadoop, there was a lot of coding written in Java, right? But people started migrating from that to other environments. So to overcome that Apache, they have introduced a component called Pig. Pig has attracted that developers, right? Very less coding, simple syntaxes. But Pig, we use Pig Latin language. But soon after, like when Apache Pig, then Apache came up with Apache Spark. It is also data flow language. Pig is also a data flow. But in Pig, the entire data flow is converted into one MapReduce job. But in Pig, the entire data flow is converted into one MapReduce job. But again, MapReduce is bad, I said, right? Yes. See, after Pig, Spark was introduced. After Spark, Apache again introduced one more product, like Apache one more introduced Flink. But soon after Spark was introduced, Apache Flink was introduced, and people who already got updated with Spark, there was a people they used to, there was a talk, right? Like Spark will be away from the market as Flink was dominating Spark, and Spark will be going away from the market. Yes, it was true in the 2017, 18, 19, right? Yes, people who got already updated with Spark, they said like Flink was dominating. Yes, it was true. But here Spark and Flink, both purpose and objective is same. Their purpose and objective is same. But in the earlier versions of Spark, Spark was weaker in machine learning. But the heart of analytics is machine learning only, right? So before Spark 1.6, Spark was weaker as compared with Flink. Before Spark 1.6, Spark was less than Flink. Spark was weaker as compared with Flink. But from Spark 1.6, Spark introduced powerful libraries for this machine learning, streaming, right? For this machine learning, streaming, these things, right? Yes. Yes. So from Spark 1.6, it came up with powerful libraries for all this ML streaming for this interactive queries. And from Spark 2.0 onwards, 2.0, from there onwards, Spark has totally dominated Flink. Spark dominated Flink. Now you cannot see that Flink. You are not able to hear that word Flink, right? Yes. Spark features and advantages, right? Now, if we just sum up all the features and advantages, Spark features and advantages, right? Yes. In-memory computation, in-memory computation, which you are not going to see in HANA. Sorry, not in HANA, you will have it. In-memory computation, which you cannot see in Tej. Distributed execution, which you are not able to see in HANA. Good for iterative algorithms, and it is not, you are not able to see in MapReduce. Transformations can be reused, which you cannot see in MapReduce. Flexible parallel process. Very high speed. Supports advanced analytics. Multi-language support. Yes, multi-language support and parallel processing and lazy availability. These are the main speed, that is the features and advantages, right? Yes. Mainly, if I talk about Spark data objects, RDDs, RDDs, resilient distributed data sets. Mainly Spark data objects, resilient distributed data sets, RDDs. Spark data objects are called as RTDs. RTDs are subdivided into partitions. RTDs are subdivided into partitions. These partitions are distributed across multiple RAMs of multiple slave nodes. These partitions are distributed across multiple RAMs of multiple slave nodes. Spark data objects are called RTDs. They are divided into partitions. These partitions are distributed across multiple RAMs of multiple slave nodes. Generally, Spark is going to run on a cluster. Spark is going to run on a cluster. What do you mean by a cluster? Group of systems which are interconnected. One will be the master, remaining all will be the slave, that we called as slave nodes. So your data is going to sit in the slave nodes. Data is going to get distributed and getting stored in the slave nodes. RTD, Spark data object RTD, right? Its programming style is data flow. Data flow means what? Sequence collection of pipe. What do you mean by a pipe? Pipe means any data operation like loading data, transforming data, filtering data, grouping data, merging data, sorting data, etc. All this, right? Yes. Even in Spark, data flow is executed in sequence. In Spark, data flow is executed in sequence, that is RTT by RTD, one after the another, with in-memory computation feature and persistence feature. With in-memory computation feature and persistence feature. Yes. And persistence feature. In Spark, two RTDs can never execute in parallel. Two RTDs means two Spark data objects can never execute in parallel. But if they have 30 partitions, if they are divided into 30 partitions, the 30 partitions can execute in parallel. They can execute in parallel. Yes. Understand here? So this is Spark data object. Spark data object is called as RTD. This RTD is divided into multiple partitions. P1 partition, P2 partition, P3 partition, P4, and a P5. These partitions are stored in RAM 1, RAM 2, RAM 3, RAM 4, in system 1, in system 2, system 3, system 4, system 5. All these systems executes in parallel. Parallel processing you are going to see, right? Yes. Hmm. Yes. Spark data objects are divided into partitions. The partitions are stored in the memory, that is memory level. Right. They are stored across multiple RAMs of multiple slave machines and are processed parallelly, right? Yes. Because of which we see very high speed. See how these RTDs are computed, right? So we know automatically it is taken care by the framework. You no need to do anything here. Into how many partitions you want, give that number of partitions you want. Remaining everything taken care by itself. Yes. So here RDD1 using Spark context write text file, the file path. So the first RTD1 is created. RTD1 is created. From that RTD1, if you perform any filtering operation, like based on some condition, the output of it, whatever you get is an RTD2. The result, the transformation or the output, what we get from that is a RTD2. Again on this RTD2 dot, if perform like some mapping activity, some other grouping activity or something, RTD3 is created. Again on this RTD3 dot group by RTD4 is created. All these RTDs, right? Finally, if we say collect some action, if you performing, then only this entire things gets executed. Understand here RTD1, the output of this RTD1 is input to RTD2. So the output of this RTD1 is input to RTD2. Similarly, the RTD2 output is input to RTD3. The RTD3 output is input to RTD4. So once this will be loaded, see where all these four RTDs will be stored in. Try to respond. I want the sessions to be interactive. Where these four RTDs, the Spark data objects will be stored.
In memory, right?
Understand here, one RTD size is 2 TB, you think, this file size. RTD1 is 2 TB, then again RTD2, RTD3, RTD4. Maintaining 2 TB RAM is a bigger task, right? Maintaining that much huge RAM, 2 TB. Okay, RTD1 can fit into the RAM and it's divided into partitions stored in the RAMs, right? And are processed. That output is collected and RTD2 and its partitions gets loaded now. RTD2 partitions gets loaded and RTD2 got computed. Now RTD1 and its partitions, everything gets removed. Once RTD2 has collected the RTD1 output and got loaded and computed, RTD1 gets removed from the RAM. Why? Because all these RTDs cannot be accommodated into the RAM. Because RAM, if RAM gets filled, it cannot accommodate the new RTDs, upcoming RTDs. Your job is going to be failed. So RTD by RTD it gets loaded, and RTD by RTD it gets removed. Once RTD2 output is collected by RTD3 and it's divided into partitions stored across multiple systems, and when it got processed, RTD3 and its partitions gets removed from the RAM. Similarly, from RTD3, RTD4 gets generated. It's divided into partitions load across multiple systems. Once this RTD4 is processed, RTD3 gets removed from the RAM. Once that RTD4 output is collected by the client, RTD4 and its partitions also gets removed from the RAM. Now, how many RTDs in the RAM, everyone? How many RTDs are available in the RAM now? No RTDs in the RAM, right? No, you can trigger the next flow. You can trigger what? The next flow.
Yeah.
Okay. This is what the RTD computations, because if you load all that, if this is a small flow, assume that you got some 40 RTDs, a bigger data flow. 40 RTDs can't be accommodated in the RAM because single RTD only it's a bigger data volume, right? So RTD by RTD, they get loaded and processed and gets removed. And final output will be collected. And final after collecting, the final RTD also gets removed from the RAM. Okay. So just we'll be discussing about this RTD computations, fault tolerance mechanism. So we have got Spark has got powerful fault tolerance, and there is one more feature, persistence feature. I'm supposed to discuss, right? Persistence feature in Spark. Yes. Persistence feature in Spark. So yes. So this is just introduction to Spark, right?
So, sir, when you say that like it is fault tolerant and resilient, so you were explaining like that RDD flow, right? How it gets partitioned. Um, so if in case in any of the steps, if it fails, then how does that entire flow uh, how does it achieve the end goal? That's what I'm trying to understand.
See,
Because this is like
understand here.
yeah,
RDD1
mm-hmm.
is RTD2. RTD1, RTD2 is divided into multiple partitions, P1, P2, P3, stored in S1, S2, S3. So this still it is available. This is also available still during this computation of RTD2. Suddenly the system 2 is down. As they are machines, if they are down, this P2 partition is lost. P2 partition is lost means the job will be failed. Means what happens in this case? Once this RTD2 is computed, only this RTD1 output, these partitions will be removed. But still now as this is, then how Spark is going to regain that lost partitions means Spark automatically executes. It will deallocate all these partitions from the RAM. Deallocates means removes all these partitions from the RAM.
Mm-hmm.
And it is going to take this RTD1 output as input again, and is going to reload in other systems like S4, S5, and S6. Which one? This P1, P2, and P3 partitions, this time it is loading into another systems other than the system which is down, right? So
Yeah.
what
So this
happens?
is a slave, right? I mean, these S4, S5, S6 are the slave nodes, right?
Slave machines, right?
Okay.
Yes. So it is what happens whenever any partition is down, immediately Spark will reinitiate Automatically the flow means it will collect the output from this RTD1 and loads into systems either other than the system which is down, any other systems. Even it can take S1, S3 also. It loads and it gets loaded and executes. Now, once this execution is done, once this output is, these things will be removed. Right?
Okay.
Means this is what if that current RTD case one, I can say this as case one. Current RTD partition machine is down. If case two, right? If previous RTD machine is down, RTD1 is there, here RTD2 is there. Here we have got divided into three partitions, P1, P2, P3. P1 stored in S1, S2, and S3. But here, understand previous RTD, this is previous, this is current. In the previous example, if current RTD partition machine is down, but RTD1 also divided into partitions, right?
Yeah.
When collecting this output as input, during that collecting the output from RTD1, RTD2, when collecting that output from RTD1, suddenly this P3 is down. Suddenly this P3 is down. In this case, so still this RTD2 didn't get the partitions. It's collecting, but the P3 partitions means S4, S5, and S6. This X6 is down. Then in this case, the flow will be re-executing. The flow re-executes. So how this RTD1 created from a file, right? Again, it is going to re-execute from that file and RTD1 will be recreated again in different machines and that gives output to the next one. Here, one way it is good, one way it is bad.
Yeah, because sir, if there are like a lot of steps, right? In a data flow, say I have 100 steps, and if something goes wrong, say at the 90th steps, right? Then again, I don't know. I mean, I'm
Re-execute
just
from the
trying.
beginning. So, okay, for that Spark has another feature, persistence.
Yeah. Okay.
Spark has got the feature like persistence for it.
So is it that in intervals it keeps on persisting in the
Persist,
backend or?
yeah, 1 second. Persisting, when it is persisted means no need to execute from the beginning. From the persisted already onwards, you can execute.
Okay. Okay.
So no need to come from the 90, you said from 90th step failed means no need to execute from the one. If
One.
R70 is persisted, from R70 you can execute. Persisting means making that RTD available in the RAM permanently.
Yeah. Correct. Yeah.
Yes, in such case, if any RTD like R70 or R50 is persisted, you can execute from R50 to R90 instead of re-executing from R1. So
R1.
in the tomorrow's class, I'll be briefing you about that persistence, one more important feature of Spark.
Okay.
So I want more interaction from your side, right? Everyone, be free, can ask queries. So, okay. So one way this is good, one way this is bad means good means it is you are making the flow to execute. The flow is executed. The flow is not failed. Bad means already you have executed R1, again you are re-executing it. You are making it to re-execute. That is okay. Fine. So you
That
can
is a
see
trade-off actually, sir, between performance and this thing, right? I mean, does it impact the, because we are re-executing, right? So lot of IO operations, right? Again, we have to execute. So that is wastage of.
in this case, if previous whenever you are taking output from and as an input, right? If the previous one is down, then you need to re-execute from the beginning. Or in such case, the persistence will work. If anything is persisted previously, from there you can continue. If nothing is persisted, you need to start from the beginning.
Okay.
Okay. Now you can see in brief, in depth, I'll be discussing about this PySpark. You can see the course content, Apache Spark, need for PySpark, PySpark session, PySpark context, parallelizing, repartitioning, broadcast variables, PySpark RTD computations, directed acyclic law of steps in RTD computations, RTD persistence, persistence features, persistence options, memory only, memory underscore SCR, disk only, disk and memory and disk, PySpark core computing, fault tolerance model in Spark, different ways of creating RTDs, word count example, creating Spark data objects, increasing the number of partitions, aggregations over structured data, groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations, process of group by key, process of reduce by key, various inbuilt transformations, various inbuilt actions and transformations one by one with many working examples. And one more important thing in PySpark, data frames. PySpark SQL data frames, creating a tabular structure, creating a data frame, empty data frame, creating data frame, creating a data frame to pandas, struct field, struct type, row class, select, collect with column renamed, where, filter, drop, order by, group by, join, union by name, UDF map, flat map, for each fill null, pivot, partition, right? PySpark SQL functions, aggregate function, window functions, date and timestamp, JSON functions, reading and writing to JSON file. PySpark various built-in functions when expr, lit, split, translate, overlay, explode, this map value struct, count. In this way, many functions, right? PySpark external sources, Spark and Hive integration, Spark and MySQL, working with SQL statements, narrow and wide transformations, additional adding of new rows, dropping of rows, handling nulls, writing data to external files, deployment local and cluster, PySpark applications, stages and tasks, drivers and executor, building Spark applications, deploying Spark applications to cluster and tuning, performance tuning, right? PySpark streaming concepts, integration with Kafka and PySpark ML lib, right? PySpark machine learning library, right? Yes. So this is what I'll be discussing, right? Yes, this is what I'll be discussing as part of, in brief, in depth, you'll be getting the total knowledge of this PySpark. You'll be getting great command by this end of this course.
Yes, yes, sir. But I was just thinking, looking at this entire syllabus, right, that you have shared,
Hmm.
will we be able to cover it in 10 weekends? Like
10 to,
if you look at this one, right, if you go down, so many functions to cover, right?
yes, yes. And this is given like 10 to 12 weekends it goes. 12 weekends.
So
So,
tomorrow we are going to have a class because I joined your class after 3 years. Earlier I had done Python in December 2022, I think. Yeah.
okay.
Yeah. So
Yes. So yes, we'll be discussing all this. Even I'll be taking some bigger sessions whenever required, right? I'll be pre-intimating. So some bigger sessions, I'll be taking some 3 hours, 4 hour sessions also. I'll be just intimating you before in advance on the preferred
sure.
timings, because you need to spend some extra time. Not only that,
Mm.
means I'll be extending the sessions, right? Yes.
Yeah,
Because
because
if you want to work with more working examples to show all these things, because
yeah,
PySpark, you need to know about all the functionalities, many functions given, no need to write huge codings, many inbuilt functions are given, right? So you need to know about these things, right? So today, if you see, yes, 1 second. So the offerings from my side, you'll be getting the recorded session video of this each and every session, right? Soft copy of this class notes, clear notes of this, assignments and tasks to work, and a WhatsApp group will be created by me where you can directly have interaction with me. Live interactive hands-on sessions. You can also do parallel along with me the practical parts, where if you can also do parallel along with me. If you got any errors or environment related errors, can just check it and interview questions, right? Yes. So all the sessions are interactive. At any point of that, if you have got any query, immediately you can ask. No need to wait until the end of this session, right? Immediately, whenever you got any query, you can ask that. 1 second. And you can see in the chart, a big message is given by this online team. The course content, the contact details of the online team if you got any query, and their course content details, the payment details, their account details, and even like Google Pay or Paytm details are given. And don't forget to share the screenshot of your payment to that mail ID that is provided. Then only they'll be forwarding you the paid link. Tomorrow also we have a session. We'll be discussing more on this PYSPARK competition, more discussion on this. Yes.
So one question, sir. Today I am not seeing a lot of people joining. It might be because of the holiday.
Yeah, big
So,
weekend is there. Big weekend is there. Right.
but are we going to continue?
No, already many students got enrolled. They have already
Oh,
got enrolled, but they are following, they'll be following videos generally. But later, once they'll be attending the sessions, right, for the doubts clarifications. Either Saturdays and Sundays, many students, they have already got enrolled. Some have already purchased the videos. Some already they got enrolled. In the next week, you will be seeing them, right? Yes.
okay. Yeah, that's what I wanted to know because I am in another different time zone. So I was just thinking because this time suits a lot. So I didn't
Yes.
want that because I don't see a lot of people, then we are not having the sessions. That's why I asked.
Mhm. Okay.
Great.
Fine. In the next week, you can see, right, many students who have already
Yeah.
joined, who got enrolled, right?
Sir,
Mhm.
Python is also mandatory to learn this course.
Python basics, right? Python basics are required for this. So,
Okay.
if even if you doesn't know Python, right, just like I'll be briefing you about the syntaxes of Python before I go with the practical part.
Yeah. Okay.
So this will be fine, right? So
Yeah, but
yes,
we are going
yes.
to have the class tomorrow morning, right? Oh, sorry, tomorrow I mean
Same time at
Sunday.
tomorrow at 5:30, 5 o'clock. Tomorrow
Yeah.
at 5
Okay.
o'clock, you'll be having the class. I will be discussing more on this. So try
Sure.
to join the sessions, try to be regular, right? So don't worry, you will be getting, you can see next week, we will be seeing a lot of students getting joined, right? The, many students from the next week, they'll be joining just this week introductory session. Last week also some introductory session was given. Many students got joined. So from this week students, last week students, next week they'll be attending. Last week there was a demo conducted, was Saturday and Sunday. This week also separately, this is an add-on batch.
Hmm.
Last Saturday and Sunday there was a demo that again I said this week they won't be attending. Next week you people and those people both will be attending, right?
Yeah, but what will be the timing of the batch, sir?
Timing of the batch, right? Yes, 6 p.m. to 8 p.m.
6 p.m. to 8 p.m. Yeah, okay. On weekends, right? This is a weekend
Weekends,
batch.
weekends,
Okay.
Saturday 2 hours, Sunday 2 hours.
Yeah. No worries. Okay. Works. Okay.
Okay,
Thank you.
and any other queries, right? So just you can see that. So get enrolled for getting the videos, notes, and adding to the group, right? Tomorrow also, if people can attend, same link you can follow, same timings, right? Yes.
Yeah.
Thank you for your time. Thank you. Meet you tomorrow. Bye.
Thank you, sir. Thank you so
Bye.
much.